Hello everyone, welcome back to the Rough Cut channel. I was looking at the one of the books that one of the subscribers mentioned, the Whalen book, How to Make Planes, I guess, the second book. So I have a copy of it. I was looking through it. It's a nice book. I would consider it an entry-level book only because I think it leaves out quite a bit. And it motivated me to make this video because I realized that if you are tempted to sort of create your body of knowledge from these books, there's going to be a lot left out. So I want to address two things today that are specific to plane making that I find are either vague or not mentioned in the book at all. So let me get into that right now. The first thing I want to talk about is what I call crossover. You've seen me mention it once or twice in my previous videos, but I want to take the time to address it specifically so that you'll get a better idea of what it is if you're in the position of designing or making your own plane from scratch. If you're copying a plane, it's probably not going to be a problem because it's already in the original plane that you're copying. If you copy it faithfully, you'll get the same result. However, if you are in the position like I was, where I designed a plane from scratch, not knowing about this, you'll have to address this, and that's the purpose of this video. So, what is crossover? What I call crossover, it's a name that I came up with myself. I don't know if there's another term for it or if there's a part of the plane that specifically addresses this issue, but it's where the contour of the blade passes the extreme edge of the actual cut and goes into the stop slightly, so that there's a portion of the blade that's not being used to make the cut, that's within the stop in the body of the plane. And that's what I call crossover, so that you get 100% cutting action. Now first, let me explain to you what happens if you don't have crossover. This is how I discovered it. I created this plane, these big molding planes, and it cuts this profile. And before I put the crossover into it, what happened was there was a small section of the profile right here, right where the stop is. So the stop is running along this edge. And right here, for exaggerated effects, there was a small bead right there. And what happened was, no matter what I did, no matter how I held the plane, no matter how I pushed it, I could not get rid of that bead. And as I still had whatever part of the profile I had at that time when the bead manifested itself, I could not advance the plane downward because no part of the blade would actually cut that little tiny section of wood that raised up like a piece of wire right there. So the part of the plane that addresses that is this part right here. So what I did was I added this piece of brass and I moved the line of the stop over so that part of the blade is now slightly behind that stop, and that's what I call the crossover. Once I did that, I got 100% cutting action. So if you have a plane with a complex shape and it's a side escapement plane with spring angle, you have to have that. It's not an option because the plane will not cut properly. So it's pretty much self-explanatory. If you have an old plane, you'll be able to see that. If you're making a new plane from scratch and it's not a copy, you have to introduce that feature into your plane or it's not going to work properly. So that's the issue of crossover. Now, the other issue that I'd like to deal with is spring angle. It's addressed from time to time. I think a lot of people understand what it is. Sometimes when you see diagrams or drawings of planes, you'll see a marking on the side of the plane which represents sort of like a visual indicator of what the spring angle is. But what I want to do is I want to address it from the standpoint of how you determine the spring angle as a plane maker. So that even if you pick up a plane, to understand why it's configured the way it is from somebody else making the plane, or why you would configure it that way if you were the person making the plane. It's the same. Each person, whoever makes the plane, is bound by the same geometric rules. So let's try and understand what spring angle is. Now, first of all, let's look at planes that don't have spring angle and see what the common feature is. I'll reveal what the common feature is once I show you the planes that I'm looking at. But these planes do not have spring angle. Okay? This is the 1-inch hollow plane. You can look at the mouth of the plane right there. There is no spring angle in hollows or rounds. Okay. Let's look at this joiner plane. This joiner plane, you can see a very small mouth between the front of the blade and the body of the plane. There is no spring angle in a flat bottom plane. I don't have any more planes here to show you, but that's the idea. Now, let's look at a plane that has a spring angle, and let's look at the mouth of the plane for that one. And that would be this plane. And if you look at the mouth of the plane, you'll see that it maintains a consistent distance in front of the cutting edge of the blade. And the reason why that you would want it in a plane like this is the same reason you want it close in all your other planes, and that's to get a smooth cut. The way the geometry of the way the cutting edge of the blade lifts up the wood and then curls it, and it evacuates up into the mouth or the throat or however into the escapement of the plane. That cutting action has to be smooth. And the way that you get a smooth cut is to build it into the geometry of the plane with a tight mouth. You cannot get a tight mouth with a plane that cuts this shape without putting the spring angle in. Now, I'm going to tell you why. What I did was I have a drawing. So this is the other blade from the mate to that plane. So that blade looks like this. And what happens is, if you imagine that there's a right angle through here, right? What happens is that generally, the general orientation of this blade, these two radiuses, are 90 degrees they're perpendicular to the general orientation of the blade. And in the case of the plane body, it's 90 degrees to the geometry of the plane body. That forces you to create the spring angle. Now, if you didn't do that, so here's what that blade looks like in silhouette. Okay? That's that blade. Now this blade right here will cut the same shape, but instead of the spring angle, you would hold the plane vertically with no spring angle, and then you'd have a blade that looks like that. And let's look at what the advantages and disadvantages of that are. First of all, this blade, according to my research, is easier to shape than this one. The other thing that happens is the distance in this profile, the difference between these, if you look at this point and this point, the difference in elevation is 0 because it's a right angle. Here, the difference between this point and this point right here is 7/8 of an inch. So you have, if all other things being equal, you have 7/8 of an inch less in the body of this plane iron to sharpen. So that's going to decrease the life of the blade. So in other words, I have 7/8 extra in this blade right here to move this profile up before I can no longer use the blade. So that's one reason why you want to put the spring angle in. But there's another reason why. When you have a side escapement plane, you have a 10-degree taper right here, which is your wedge pocket. So your blade rests against the bed, and then your other face right here is what carries the wedge. So down here at the bottom is where these two angles converge, and they're close. As you go up the escapement, they open because it's a 10-degree taper. So if you measure up in this plane, if you measure up from the lowest point of the plane and you measure up that same 7/8 of an inch, you have a gap roughly a ½ inch wide right here. So if I was to eliminate the spring angle and produce a plane that had a blade like that with an escapement, the escapement would open up. So instead of being parallel like this, I'll show you with this one, instead of there being a consistent opening in front of the blade, parallel to the face of the blade as it sits on that bed, what you would have is, the closer it got to the escapement side of the blade, the space in front of the blade would open up. You wouldn't be able to maintain that parallel configuration. It would open up because it would be going up the escapement. That means that you couldn't get a smooth cut. So that's the second reason why you want spring angle. So the first reason is, like we said, that you're going to have more life in the body of the blade because of the way it's configured for grinding purposes and sharpening purposes. The second reason is going to be because if you have a side escapement plane and you put that kind of funky blade in it, you're going to open up the throat in front of the blade and you're not going to be able to get a smooth cut. It's not going to be a plane that's worth using if you choose to do that. Now, there's another reason why, and this is probably the most important reason why. But what I also would like to point out is that these three reasons working together compel you to use the spring angle. The third reason is probably the most important reason, and that is that when you use the plane, so here, for instance, here, this is just a small section, but just imagine that this is your, like a tabletop. This is your wood oriented this way, and it's just the edge of your board. So it's be clamped to the table or whatever. So now when you place the plane on that board, you have downward pressure and you have sideways pressure. And that's where the stops come in. So right here, this stop is what's going to ride all the way. So when you have, when this starts out, right, when you begin the cut, you're going to have your stop resting right there. And that stop is going to ride all the way down and perfectly orient the plane in relation to what you're cutting, and you're going to end up with this. And then you have your depth stop back here, and once that hits the top of your board, the plane stops cutting. So if you were to configure this differently, if this was your end product, and you wanted to insist on holding the plane this way with no spring angle, using a blade that looked like that, what you're going to find is that this is going to want to skip around, and it's going to be much more difficult to use. So by having the spring angle, you're producing a plane that's easier and more reliable to use because of the guide and the stops and the cutting pressure that you're able to apply downwards and sideways. You won't be able to do that if you're holding it vertically. It's not going to be manageable, especially in hardwoods. Especially in longer lengths, you're going to have all sorts of deviations and stuff, because this is a plane that's basically meant to be used freehand. You could use straight edges like I do, but that's the whole idea. So that's the third reason why. It's probably the most important reason why. If you didn't have the other two reasons, that alone would make using the spring angle worthwhile. So now let's talk about how you calculate the spring angle. The first thing that you have to do, this is what you would do if you had a profile that you wanted to create a plane for from scratch. Obviously, if you're copying a plane, if the spring angle is already built into it, you're just going to copy it. This is how you would do it from scratch. You've seen me do it, I think, at least once, maybe twice, but I'll try and illustrate it for you here. Let me use a piece of steel as a straight edge, and then you'll be able to see. So right here you have your profile, okay? And then what you have here is basically a straight line that's going to connect this point right here below this step and this point right here. So right here, is your spring angle. So you could see part of this is above the spring angle, and part of this is below the spring angle. That's okay. That's okay. If you look, now we talked about as you go up the escapement 7/8 of an inch, the escapement opens up a half inch. Okay? So right here, if you look at how much of this passes above the spring angle, right? The piece of steel, you'll see that it's about let's call it 3/16 of an inch, a little bit less than a quarter. What happens is by keeping that amount either above or below that straight line, you're able to configure the mouth of the plane so that it looks like this. So as the profile of the blade goes up or down in relation to the escapement, it remains generally parallel to the front edge of the blade. Now, in an extreme case, you might have a section of the forward mouth of the plane might come a little too close to the blade and confine it, create obstructions in terms of the way you're pushing the blade, the way you're the way you're generating the shavings, and then you would just take your float and slightly open that up. So what you're looking for is not that it's absolutely parallel, because you can't have that. The only way you can make it absolutely parallel is if you have a flat body plane with no spring angle. So we already know that if you have a complex shape in your blade, it can't be perfectly parallel. But you can get it to look like this. And that's the whole idea. And then from that configuration, with that spring angle, and the way you're going to open up and tune the mouth of the plane parallel to the front of the blade, you're going to be able to get cuts like this. That's the whole idea. So, the fourth reason for having the spring angle is so that you can configure the body of the plane so that the mouth is parallel to the cutting edge of the blade. Again, if you don't do that, you're not going to have a plane that you're going to enjoy using. It's probably not going to function very well, and it's going to be difficult to get a smooth cut. So these are things that I find either are not explained at all, or are not explained in enough detail to give plane makers an idea of what they're dealing with and why. My training background, in the way I was trained, the way I like to be trained, is starting off at the very, very low level, so that I have a full understanding of things like geometry in the planes before I start making planes. And so I'm not really interested in shortcuts, because however long it takes me to learn this information benefits me in the long term. So shortcuts really do me no good, because I don't want to waste my time later on getting to the point where, like I was in this plane. So I'm admitting I made a mistake. I made this plane without the crossover, and then I had to add the strip later, and so on and so forth. But now, what I have the opportunity to do with something like that is to tell you why, so that you're aware of it, so that when you make your planes from scratch, you're aware of things like crossover, and you're aware of things like spring angle. Now, one more thing about the spring angle. When you have your drawing of your profile, and then you connect these 2 points with a straight line, what you're going to do is you're going to use your protractor, and that's how you're going to lay out the body of your plane, and you're going to create the angles for the stops and the angles for all the steps and so on. So this edge, this face, this step, this edge, and this face are all calculated based off the spring angle. And then what's in the middle is 90 degrees to the body of the plane. So that's why when you see me make my drawings, for instance, in the OG molding plane piece that I did about 1.5 or 2 years ago, you see me make the profile of the finished piece, and then you see me draw the plane in the same drawing, because it's the easiest way to conceptualize both of them at the same time, is to draw them both and put them on the same drawing. So that's really all you need to know. You'll see me do this again and again in the future. You can look back at my past videos and see that. You'll probably see other videos on the internet. There's a lot of plane making videos. There's plenty of people with better outfits than me that make molding planes and hollows and rounds and all sorts of stuff. They're great channels. I'm sure of it. I don't watch them, but I'm sure they're out there. And so when you're seeing all that, you're going to know that there's two things involved that may or may not be discussed at length. I'm taking the opportunity to do that now, and that's crossover and spring angle. So now you know a little bit more, and we can take it from there. So that's all for this episode on the Rough Cut channel. Thank you for watching. Thank you for subscribing. Thank you for liking, disliking, commenting, asking questions. It's all good. You can watch these videos on Rumble. You can join me on the Locals channel. We hang out over there. We're going to discuss books, post pictures, post your work, discuss my videos. Whatever we're not doing in the YouTube comments, we do on the Locals channel. Thank you very much, everyone. Stay strong.